the last lecture of the day. The title is A New Way of Network Science from Fantasy to Applications. And the lecturer is Milan Janosov. So hi, Milan, and welcome. And thank you for making the time to participate in the conference. And in short, this talk will focus on unusual dimensions of network science via several recent case studies and applications. It should be pretty exciting.
Hi everyone, my name is Milan and I am a network scientist. So surprisingly, today I brought here a few stories that will combine data science and social networks and network science in a few different topics that will cover, on the one hand, things that may be just simply fun, but also have, let's say, serious business case implications. But before jumping into the depth of science and applications here, let's just have a few words about the history of network science. So, network science, as we know it today, is only dating back to the 90s, but actually its mathematical foundations are going back to the 17th century. So that was the time in about the 1736 when Leonhard Euler, the mathematics genius, started to walk across the city of Königsberg and realized that even though there are 7 bridges of the city, there is no way to walk across all of them just touching them, everyone, just a single time. Even though this sounds like a very, let's say, niche problem for urban planners, it really stuck into the head of Euler, and he didn't stop until he figured out how to resolve this problem. So his resolution turned out to be the definition and the foundations of graph theory, a branch of mathematics that is dealing with graphs. But what are graphs? Let's have a quick look on a very standard, let's say, generic graph and the main anatomy of this graph object. So, a graph, or let's say a backbone of a network, consists of 2 types of things. So it has nodes, these nice circular shaped objects, and the links that are connecting 2 different nodes of the network. So far it's very simple. These nodes can be parts of the city, links can be bridges connecting these parts of the city separated by the river, or many other things. Just to illustrate how diverse networks definition could be and how diverse networks and nodes and links could be, let's recap a few different versions of networks. For example, our brains are networks. In there, neurons and their axons are the nodes and the links. Similarly, we can talk about an entire zoo of social networks, from friendship networks to marriage networks, online social media from Facebook to Twitter, following relationships, friendship relationships, all of them are networks. But we are not stopping here with social networks, because even cities, as in the case of Euler, you have seen already, can be taken as networks, or even the World Wide Web is a network in itself. So, it seems that networks are truly everywhere, so why not in our favorite Netflix show, right? So that's how I ended up working on a small network project that was targeted at The Witcher, which is a fantasy novel series written by a Polish author and later earned world fame in the gaming community thanks to its computer game adaptations. So Netflix has seen that The Witcher is really popular amongst nerds and video game players, so it turned out that it might be a good idea to transform The Witcher into a Netflix series as well, and this theory and this hypothesis was actually verified by the TV show that was aired later in 2019 with a spiking popularity even on Google Trends. So that was kind of my starting point here at this project as well. In fact, at the time when I was waiting for the 2nd season of The Witcher coming out, which was in 2021, December, that was the time when I was thinking about how could we capture the social network of this show just right after finishing reading the books. And well, that was the time when Witcher new season came out, but surprisingly it didn't have such a resounding success than the 1st season. But you will see also in the graph just behind me that I was covering very well, that turned out that the 2nd season's popularity was not even half of the 1st one. Yet we learned a lot from this series, besides the adventures of Geralt of Rivia, And some of these adventures were actually wrapped up in my social network map. So the social network map I made here and wrote a short article about was actually featured in many or several news outlets that were, let's say, a bit further from the traditional network and data science journals that I was expecting, for example in the GameStar. And that was a very interesting example for me to see that how far networks can reach outside of the scientific community if we are kind of phrasing the questions and the context right. But what was exactly the context here and what was the point this network was making? So, I went back to the books. I read, I think, maybe 8 or 9 books of The Witcher, and it was quite a good reading and I can recommend it to all of you. But also the question comes that what do we learn from thousands of pages and millions of characters? Well, we certainly have a very good experience of reading all these things, but it's also quite a lot of information to digest and to kind of keep in our mental cache memory for a long time. So the question came to me that how could I actually draw up the network map of The Witcher? And I realized that putting together all the things that I read and that I remember is not really adding up. So I would need something more solid, more scientific, more data-driven than just relying on my, let's say, medium quality memories here. And that's why I started to look for the text. And as you have seen, it's quite some text, and this example is only just about 2% of the whole Witcher franchise. So it's a lot of text to look at, a lot of text to keep in mind for us, but not so much text for a Python script to process and store in the computer's memory. So I went for all these texts, and first I started to map every character's name into the text, and then I simply marked every sentence where these characters were mentioned. So this way I ended up with a list of mentions of every character and also the information of which characters or which pairs of characters were mentioned together. So let's take a moment here and think about what kind of data do we have here. We have characters and we have sentences that are mentioning characters near to each other. So we have nodes, the characters turn into network nodes, and we have the relationships, how frequently they were co-mentioned in the storyline. So if we apply this simple method or simple logic to the entire corpora of The Witcher, which is about 5 million characters if my memories are correct, then we will arrive to quite a substantial network. And how nice and substantial this network is will just illustrate my image right here. So here you can see actually 8 or 9 different books condensed into one single social map. Here on this network, every node corresponds to one individual, one character of The Witcher, and the links are actually based on the co-mentions in the different storylines. A network figure like this already kind of lays out in an objective, quantitative way how the storyline looks like. You can see the main characters here, for example, Geralt of Rivia is the largest node, there is his best buddy Dandelion, his love Yennefer, or the other main character Ciri over there. So you can kind of see already that they are the main characters, which of course you would also guess from the storyline, but here you can actually see how they are related to each other, how frequently they meet, how these different triangles are getting closed in the story. And the network map is not stopping there. You can see the different colors, red one here, dark blue here, bright blue here, etc. These colors encode network communities. So all the nodes who are bearing the same color belong together in the sense that they are much more frequently mentioned together than with the rest of the network. If we took a closer look at these communities, we will actually understand, especially after reading the books, that all the communities are corresponding to the different storylines of the network, storylines of the book. So one community, one storyline, one block of nodes, one major logical element of the whole system. And this is kind of leading us through to the higher level point of this study, which is about building social networks from unstructured data. Because, of course, it's nice and fun to build a network from a TV show or a book series that we love. But the question comes that what's in it for us besides having a fun project and a nice, fun article to read? But the question is answered very simply if you think about any kind of organization, from startups to multi-corporations. Because here I turned unstructured textual data into a social map that highlights the influencers, the bridges, the key players, the communities, and all the main structural components of a social map. And if you think about, for example, the internal emailing system with all the senders, all the receivers, or all the meetings of a company, then you will certainly arrive to a dataset where you can also apply all the logics that we had here in Witcher. We can even go further than that and imagine a scenario where you have thousands or hundreds of documents with different actors, partners, managing partners, employees of the company, and you would need 10 people full-time for weeks digging through all these documents to figure out who is whom and how they are linked together if you wouldn't go for network science and text processing and transform all these documents, all these thousands of pages of information into a social mental map of any kind of system. So the story of the Witcher showed us how we can turn data into a social map. But what happens when we want to do something, for example, predicting the future about these networks and of the characters of the members of these networks? And this is where another story of mine, actually one of my PhD projects, came into the picture. In this project, I was at the time very enthusiastic about the Game of Thrones. So yeah, after Witcher, I guess there is a pattern here. And here in this project, I asked the pressing question of which are the Game of Thrones characters that are going to die in the next coming seasons. This was a time in 2017, if I'm right, when there was 6 seasons of the TV show out on HBO, and the last 2 are still to come. And that was also the time when I started my PhD and I really needed a project idea to finish one of my data mining courses. And then I realized that, okay, it's nice to forecast stock market data or any other kind of stuff like that. That was quite usual in the time. But it's actually quite pressing for me to figure out who is going to pass away in my favorite show and how could we use and utilize networks and machine learning to figure this out. Once finishing the project, actually I only got a B because I got so tired of manually cleaning all the data that I didn't really put much effort into the modeling afterwards. But thanks to my friends who kept bugging me about it, I finished the project, wrapped it up, wrote a nice proper article, and then got featured at quite a lot of places, to my biggest surprise, even at like fashion journals like GQ. So that was also very eye-opening for me, and kind of the first big eye-opening part that network science shouldn't just be done for the lab and for the research papers, but it should be utilized and transformed into knowledge that could be used for all or available for practically anyone who is related to or doing anything related to data. So how did this happen to our Game of Thrones characters? You have already seen in the Witcher example that we can turn unstructured data into networks. Here my data source was not the books, but the TV show subtitles, where I managed to find a very detailed data source where every scene had a list of characters and all the dialogues they had. So I ended up having hundreds of different small social units that TV shows different scenes where I know for sure who were the characters that were also appearing in these scenes. So just to repeat it again, here I have the characters as a nodes, and I have the scenes where they were co-occurred. And these scenes were actually the basis of the social network, so every person who met at least in one scene had a social type between them with a strength of 1. And of course, the more frequently they met in the show, the stronger the connections ended up being. And if we iterate this simple rule across all the scenes and all the characters, then we will arrive to this network, which has all the main characters, actually the main noble houses by color, and also their links and connections. So here, if you are familiar with the show, you might be already spotting a few familiar names like Jon Snow. And if you are familiar with it, then you already know that the Game of Thrones is famous for killing the unexpected suspects. and surprisingly and shockingly getting rid of major characters of the show. So, in the original network, you can see that there are many network nodes colored. They are actually the main houses of the TV show and the novel series. And then I recolored the nodes and turned the ones that passed away black to illustrate how many of the nodes, how many of the people actually met their ends during the first 6 seasons. And well, as you can see, there's quite some darkness coming here, and winter has literally come here as many of the nodes were turning black, which on the one hand, from a story's perspective, is of course very sad and very saddening and very shocking. But from the data science perspective, it actually means that there is quite a lot of training data for us. Because here I ended up building a machine learning model where I described every node of the network, every character, based on its friendship patterns. These are also called network centrality measures, the number of friends, how clustered someone is, how much of a bridge a network node is in this network. So once we compare the before and after networks, we can easily see that there are so many people who passed away that they serve as a very good training data for a model that will predict who is going to pass away in the coming seasons and who are the ones that are likely to stay alive. To arrive to this point, we will also need to compute the so-called network centrality measures, that are numbers, mathematical formulas that describe how important every node in the network is. This importance can be measured in different ways. For example, how many friends does someone have, how many times he or she interacted with other character members, how clustered they are, how much of a bridge they are. So once putting together all these numbers, engineering all the right features, then we can also add the binary target label that someone survived or did not survive, and we can stuff all of these things together in a simple machine learning model that can do basic binary classification. For instance, in my case and in my original article here, I used a support vector machine, but it's totally up to you what would you use. The goal is to use the network features, maybe combined with other external meta information and a binary predicting algorithm. But again, as in the case of The Witcher, here might come the question, why do we do this thing with Game of Thrones? Besides, it's fun and it's interesting and it can also lead network science and machine learning to the radar of people who otherwise wouldn't necessarily be very much interested. But again, this project also has a lot more far-reaching implications for any practical project, let it be urban planning or people analytics. And a few examples that I like very much in this domain, and I've also been pursuing consultancy projects in this direction, go about the internal work and internal processes of corporations. Because we have a network and we have a binary target label, which are, in this scenario, corresponding to Game of Thrones characters and their fate, but they can also easily be converted to something very, very different. For example, we can replace the nodes by a corporation's employees and the binary target label to whether they will leave the company they are considering to quit, whether they are in the quitting process, or whether they are good enough to get a raise, whether they should be sent to a training, whether they are the ones who should be promoted. And so in a corporate internal life, these networks, for instance, based on their email communication, could be utilized to many different factors, many different directions that could support internal organization development. And just one last example where we can use these networks is that if we are not focusing to the inside of the company but to the outside and the product they are using. So let's assume that you have many customers and you want to figure out who you should get a voucher or a reward or some coupon codes, or who are the ones that are more likely to leave your product, who are the ones that are likely to churn. How could you capture all of these? And if you look at these from the network perspective, they are all converting to the same problem that we saw in the Game of Thrones scenario. After venturing out into the realm of Game of Thrones and Witcher and fantasy and network predictions, I want to show you two more examples that are a little bit further from that domain, but still might be very interesting to see as they are radically different applications of network science. After venturing into the realm of Game of Thrones and Witcher and all these fantasy series, now to close this talk off, I would like to take you to two more examples that are quite far from these exotic examples, but still very much interesting and very much in the rise in terms of their popularity. And the first of these topics is about cities as networks. At first, at least for me as a junior network science PhD student back in the day, it was a very surprising idea. But then looking back at the example of Euler, it's actually kind of the natural way of how networks are. And how can networks be how could networks and cities be mapped into each other? Well, we all know cities and maps as they are from even simple geography courses. That's just, for example, the map of the downtown of Budapest. And if we add another network view of actually the same data, we will arrive to this graph. So it's the very same thing on the left and on the right, but it's Budapest, but on the one hand it's using a geo layout, so it's technically a map, while on the other hand it's a random layout where the nodes of the network are just scattered across the space, just random. And if we add a thing called force layout, then we can actually build a continuous smooth transition from the map to the random network. And this transition kind of shows you how the network on the right can be turned into a map where the nodes are the intersections of the roads and the links of the network are actually the roads connecting these intersections. So this is kind of hinting already how a city or an urban space can be transformed into a network and giving us some information about how we can transform cities into data points and then into networks. My current understanding and my current vision about cities and networks has three different layers. The first one is the structural one that you have already seen on the previous slide. It's about the buildings, the bird's eye view of the city, how a city and the city's aesthetic look builds up in front of our eyes. And then afterwards, the second layer comes, which is about the dynamics of a city, how different processes operate on the static backbone of a city. This can be about the mobility, the traffic, the public transport network, or simply how we people move across the city and kind of link together the city's different parts by just producing these mobility patterns. And finally, the third and the most abstract layer of cities as networks is about the social fabric of the city, which means that we as humans live in a city, move around in a city, link to different physical parts of the city, but also at the same time we have friends, we have social networks, we have social ties that are kind of stepping out of this physical space of a map and building a hidden underlying social network structure that's intertwining this city fabric. And the interesting part is that we can combine all these different layers. Today we have data sources for all of them, from OpenStreetMap to Google Maps to different mobility providers like TomTom, Here, and lots of other companies and data sources, even for the geotech social part like Twitter, Flickr, or Foursquare. So we can use all kinds of data to reconstruct and build these networks and combine them and utilize them to create different location-driven spatial data solutions. So to quickly wrap up this part of the talk, we can say that cities can be broken down into tiny pieces of data, and then these can be transformed into networks at different layers, at different stages. And once we have that, we can build novel geospatial and also network science-powered solutions for different fields, from the insurtech to commerce and logistics. Last but not least, I also have a very exciting topic that we have been working on in the recent times, which is kind of about transforming networks and network visualizations and network maps into humble but contemporary pieces of art. Of course, there's a question of what is art and what is contemporary art, which I am certainly not qualified to dive into, but still I have a few interesting figures and projects to show you where we transformed network science and the products of network science analytics into actual NFT artworks. So in the first project of this line of work, we were interested in how the NFT hype was building up during the spring of 2021, and as part of the project, we mapped out the network map of an NFT platform called SuperRare. So on this network, every node is one piece of NFT work, and they are linked if they are sharing their owners. So once we did this, we arrived to a network map like the one you can see here with different colors that highlighted the different clusters of NFT artists and also different collectors. And here this was kind of an entry point where we started to turn data science and network visualizations into NFTs, which turned out to be kind of a part of this early rise of the NFT hype. I was also interested in how this super big hype around AI generated art, and again the question of what is art standing here and looking at us very much judgingly, but still I was interested in what could, for example, Midjourney draw up as a network graph. And if I'm right, for those of you who will visit the conference in Belgrade, you will also get the chance to play with this tool live at the conference. So here I was figuring out how to combine network science and some more old-fashioned physics phenomena like black holes and turning them into NFT works, and that's how they started to look like. And I think the highlight of this line of work that I was lucky enough to work with is going back to a collaboration with a famous digital artist, which is combining Flora Borche, which is combining the text mining methodology that you have seen, for example, in the case of Witcher, with the foundation series of Isaac Asimov. So I believe that this is kind of a fitting tribute for such a visionary as Asimov was, and this contribution to our sci-fi literature by turning his books into this stunning piece by Flora Borche and myself. That was it. Thank you very much for being here today with us at the Data Science Conference 2022.